task 2.3, and why it's not showing up here. Let me minimize this and start from current slide. Okay, there we go. That's not at the beginning. I don't know why it's doing weird things today. Okay. Now, and there's also got a block right in the middle. Hopefully that will go away. So if you have no questions, I have one fairly major announcement I want to make. I think I made it last week, probably twice, but I'm going to make it again. It looks like, or my impression is, that the spring enrollment is fairly low. So the administration decided to have a week of intense advising registration this week. Okay, so they haven't started yet today. They start at 9 o'clock each morning. They started yesterday, today and tomorrow and Thursday. Okay, from 9 until 7 in the evening. So lots and lots and lots of time, and that's going straight through. They'll have tables set up on 2 locations, one on the Birmingham West Campus, that new Student Success Center there on Wilson Road, just before, right where the old Winona Elementary used to stand. That's where they built the new Academic Success Center. And somewhere in that building, it's a big building, and there's a bunch of big rooms, and somewhere in that building is a big room they've set up just for advising and registration purposes. And people will be at the tables from, like I said, 9 in the morning until, and here comes somebody. Rosa is here. So let me get Rosa marked here without pulling all my wires and everything else, devices off the table here. So the top part of the alphabet is coming in fairly strong now. In the middle we have some gaps, so keep them coming. All right, and I hope, see if Rosa was the last one. Yep, 7 students. Okay. Rosa, I was just talking about, they're doing a huge push right now for getting spring advising and enrollment and registration up to par this week. They started yesterday, they go through Thursday. 9 in the morning till 7 in the evening. They will have either faculty advisors, administrative advisors, or even staff advisors. There will be someone at multiple tables. Now I know, for instance, most of you are probably general education, okay, general studies. On the Birmingham campus they have 2 tables for that. They have one for pre-nursing, one for the nursing professions, and at least one for career tech. On the Bessemer campus, these are being held in the Ethel Hall building. Now don't get that confused with the Ethel Hall building on the Birmingham East campus. That's the nursing building. That's not where I'm talking about. This is on the Bessemer campus, the Ethel Hall building, and it's on the very southernmost tip end of the Bessemer campus. That would be, if you're on the Bessemer Superhighway, there are 2 entrances off of that go into the Bessemer campus. One is up at the light where Bessemer Caraway Hospital used to be. It's now called UAB West Hospital. The light there, that's the northern entrance, okay? You can go in there, and if you do, when you go in, you'll, whoops, somebody else has come in. I believe it's probably, if I could get it to show, I think it's probably Shamari, but I'm not certain. Shamari, is that you who just came in? Okay, good. The Zoom wants to block out your names. I guess it Zoom something blocks out the names, and I have to catch it when I can, and it had you totally blocked out, but I thought it was you. Okay, so glad you're here. I was just saying that on the both Birmingham and Bessemer campuses, there are places to register for spring term this week from 9 o'clock in the morning until 7 o'clock in the evening. There will be tables set up on the Birmingham campus in that new Academic Success Center that's right on Wilson Road. You can't enter the building off of Wilson Road, but you come in that driveway that goes up to the ACAT building, and then you turn right into the parking lot for the Student Success Center. That new building where Winona Elementary used to be. Okay, so that's from 9 until 7 today, tomorrow, and Thursday. They had it yesterday as well. On the Bessemer campus, it's the Ethel Hall building in the auditorium. Now, if any of you are familiar with the Bessemer campus, I was just describing, there are two entrances to it off of the Bessemer Superhighway. The northern entrance is at the light right at the hospital there. It used to be Bessemer Caraway Hospital. It's now UAB West Hospital. If you turn in there, then when you turn in, you go through a gate, and then there's immediately a fork in the road. Take the right fork, and you go around that big building. It's called the A building. That's where most of the things are in the A building. Go all the way around it until you reach a parking lot on the other end, big old parking lot, and the Ethel Hall building will be to your right. Okay, if you come in the southernmost entrance, that's the entrance between the light and the Bessemer Civic Center exits. And here's somebody else coming in. I can't see who the name is. D, I believe it is. Okay, so let me get D here. Got it. Okay. Middle part of the alphabet is coming along nicely. Bottom part's coming along nicely. Top part's doing okay. It's just the gaps in between we're missing people. So now let me make sure that there's nobody else. I have 9 students. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got them. Okay. So D and others who have just come in, the college is making a huge push trying to get, oh, here's somebody else. Diana is here. So let me get Diana marked here, and then I'll start it over again. Sorry about this. We need to be doing algebra, but we also need to have enrollment for the spring. So sort of competing factors here. Diana, I hope you can hear now. The college, I think my impression is enrollment registration must be pretty low for spring, because they are doing a huge push right now to get more students advised and registered for spring term. And this week is when they're doing it. And they're doing it from, oops, here comes somebody else. Let me see if I can get who this is. Ashford's here. Okay. Let me get Ashford here. Okay. Top part of the alphabet is coming in stronger again. Bottom part's doing quite well. Middle part's doing quite well. But there's some gaps in between. So hope they'll keep coming. And oops, here's somebody else. Ivan's here now. Let me get Ivan here. All right, good deal. Keep them coming, folks. That's 4, 5, 6, 7, 8, 9, 10, 11, 12, I think. Let me make sure that's how many nobody's in the waiting room. Nope. So it's 12 students. A good even dozen here. Okay. Ivan and others who have just come in, here's somebody else. I think this is, pretty sure it's Shay. Yeah, Shay has just come in. I believe it was. They black out as soon as you show up, but I thought I caught Shay before. Let's see. Just make certain that there's nobody else waiting. Yeah. Okay. That was Shay, I believe. Okay. So for Shay and others who just got here, let me say this again. Those who have been here a while have heard it several times now. The college, the enrollment, the registration for spring term must be quite low because they're making an enormous pitch trying to get more students registered, advised and registered for spring. And so what they're doing this week, they started yesterday and go through Thursday, from 9 in the morning until 7 in the evening, they are having a huge, not quite face-to-face, but pretty close to it, advising registration things on both campuses. On the Birmingham campus, it's in the new Academic Success Center. That's the building that's on Wilson Road, but you can't enter it from Wilson Road. You have to come in that. There is an entrance just past the building on Wilson Road. Drive up to the back side of the building and go in the parking lot that way. And it's somewhere in that building. There's a big room, and what they've done, they've set up tables, and at the table there will be advisor on one end and the students on the other, or I don't know how they're doing it. I haven't seen it. I can't be there because of my health situation, but they have I think a partition of plexiglass you can hear through, but there will be protection there. Everybody has to be in mask. Everybody. Before you enter a building, you have to be masked. They may have some masks that they'll be passing out for anyone who comes to register and forgets the mask, but don't bank on it. Bring your own mask. Wear a mask when you're on campus. That's always, okay? So when you are, but the advisors will be masked. They'll be mostly faculty members, but there'll be some staff members. There'll be quite a few administrators will be helping out with it. They'll have tables for every thing. Most of you are probably general studies, so they'll have a table for general studies. They'll have a table for pre-nursing. In fact, on the Birmingham campus, they have 2 tables for general studies, 1 table for pre-nursing, 1 for nursing professions or health professions, 1 for career tech. On the Bessemer campus, if my memory's right, they have 1 general studies, 1 pre-nursing, 1 health professions, and 2 tables for career tech. They'll also have financial aid tables set up. They'll have registrar table. I mean, anything you need to register will be in that room. Now, on the Birmingham campus, that's the room in the in the Student Academic Success Center. I don't know if that's upstairs or downstairs, but someone will be there directing. There'll be signage. You'll be able to find it pretty easily. On the Bessemer campus, it's the Ethel Hall building. Not to be confused with the Ethel Hall building on the Birmingham East campus. That's the nursing building there. Don't go there. Go to the Bessemer campus. And I was just describing, there's 2 entrances to the Bessemer campus. One at the light right across from Bessemer, what used to be Bessemer Caraway Hospital is now UAB West Hospital. You can enter that way, but if you enter in that entrance, when you go through the gates, which will be open, of course, there will be a fork in the road soon. Take the right fork, go around that big building in the middle. That's the A building. That's where most of the things are located on the Bessemer campus. It's the biggest building there. But go all the way around that building till you wind up in a parking lot just before you're going off campus. And that parking lot is at the Ethel Hall building, will be on the right when you're driving that way. If you come in the south entrance, that is the one that I was just describing. That's the entrance between the light and the Bessemer Civic Center. If you come in that entrance, then the Ethel Hall building will be on the left. When you park your car down in the parking, that's student parking down there in that big lot down there, walk around the building. Okay, somebody else has come in. Okay, Starts with a T. I couldn't see who that was. I tried to catch it, but I missed it. Is that Tommy? I believe it was. I believe that was Tommy Easley, I think. But let me go and check and make sure Tommy's here. Okay. It's going to take a minute for me to verify this. This is such an aggravating thing that it blocks people as soon as they try to come in. Yep, Tommy Easley's here. Okay. And okay. Here we go again, folks. Sorry about this. You have been here for a long time. You've heard this several times now. There's a big push to get students advised and registered for spring term on both campuses. Birmingham West Campus, that's going to be in the Academic Success Center. That's that new building that faces Wilson Road. You come in the street that goes into campus from Wilson Road, go behind the building and do your parking there. Be sure you wear your mask. Everybody on campus has to have the mask on properly. And when you get on into the buildings, there will be signage and indication of where to go for the advising. It's going to be a big room, lots of tables set up, lots of room for social distancing. Everybody will be masked. There'll be plexiglass between you and the advisor, and you and whoever staff person you're talking to. So please go. Okay, I don't want to quite say it that way. In my opinion, the best thing to do was sign up for virtual advising. Do that from home, and then once you get advised, register from home. That would be the safest. Okay, but if you want to have close to one-on-one help, then go to campus. Okay, like I said, the Birmingham campus is Birmingham West Campus, but it's right across the street from the East Campus, and it's in the new Academic Success Center. On the Bessemer campus, it's in the Ethel Hall building, which is the building, not the big building in the middle, but it's a pretty good sized building on the south end. The easiest way to get there is to pull in the parking, the gate that's in between the light and the Bessemer Civic Center. Okay, there is one entrance there, but either the entrance at the light or the entrance that I'm describing, you can get there. But if you go in the entrance in between the light and the Civic Center, that entrance, you're right at the Ethel Hall building. If you go in the light across from the hospital, you have to go around the A building, and you'll come back out at that parking lot. And the Ethel Hall building is a newer building up the hill from the parking lot on the south side. And there, if you walk around the side of the building and go up to the main entrance, which comes in not the side of the building the parking lot's on, but the other side of the building, if you come in that way, when you go through the big glass doors there, the auditorium is going to be immediately on the left. It's not much of an auditorium, it's just a big room, but they call it the Ethel Hall Auditorium. And they'll have tables set up there, plexiglass between advisors and students, between staff and students, and plenty of place to social distance. Okay, so any question on getting advised? The safest thing would be to go on your virtual advising center, get your advising there, and then register immediately thereafter. And possibly even they can help talk you through it while they've got you online. But if you want the help one-on-one and help for financial aid and help for anything else, and you want to do that, you can go to campus, either campus, Bessemer or Birmingham, between 9 in the morning and 7 in the evening. They started it yesterday. They're doing today, tomorrow, and Thursday. Okay, not Friday, only Monday through Thursday. And people will be there to help. Please take advantage of it. All right, do you have any questions? Let's see if we can get some math done today. Any questions at all? Okay, I hear none. I hear some sort of noise in the background, but I guess someone's microphone's turned on. Okay, we're in Chapter 2, Polynomial and Rational Functions. We're in Section 2.3, Polynomial and Synthetic Division, and we have just talked about the remainder theorem and the factor theorem. We gave an example of the remainder theorem. We're about to do example 6, which is the factor theorem. Okay, and this is factoring a polynomial by repeated division. Okay, now they're being very nice to you here. They say show that these two factors, x minus 2 and x plus 3, are both factors of this big old long polynomial here. Then find the remaining factors of f of x. Okay, well, how do we do that? We can use synthetic division because this has a coefficient of 1 and an exponent of 1. So does this one. So let's start the game then. Okay, coefficient 1, exponent 1, use the opposite of this number here. That's going to be a positive 2. Put it outside the box. Okay, then put the coefficients of the dividend inside. That would be 2, 7, negative 4, negative 27, and negative 18. Okay, now, just a hint. I should have done this before I wrote those down. Look at your exponents. 4, 3, 2, 1, 0, blast off. Okay, we've got them all covered. So that's why I was confident that I can go on. Skip a line, draw a line. Now that's my little rule. You'll never read that in the book, I don't think. Okay. Bring down that first number, 2. And now from this point on, you multiply and add. That's all you do. 2 times 2 is 4. Add 7 and 4, 11. 11. Multiply 2 times 11, 22. Add negative 4 plus 22 is positive 18. Multiply, that's a 36. It's not looking good, is it, folks? Okay, add, and you get a 9, but then when you multiply, you get an 18, and ding, 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 you get a 0 here. What does that 0 mean? The 0 is your remainder. Oh, here comes Ladarius. Okay. Let me get him marked in before they block him off, and let me get him marked on the roll before I forget it. Okay. Now, oh, here's somebody else. Terrell is here. Let me get him marked here. Okay. So that was adding a big boost to the top part of the alphabet, which is coming in very, very strongly there. And the bottom part of, oh, here's somebody else here. Let me see who this is, if I can see it. Chance is here. So let me get Chance here. Okay. Let me see if anyone else is waiting, because it seems like there was a crowd in the waiting room there. Okay. Let me move this to the top just to see. I don't see anyone else. We should have 17 present, which is a good crowd. Let me see if I've got 17 here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yep. I think I've got everybody accounted for so far. Now, for those who just came, oh, here's somebody else. Maybe. I don't think so. Okay. For those who just came in, we've gotten a late start because I've been making this announcement time after time after time. Basically, it's this. They're having on campus this week, Monday through Thursday of this week, started yesterday, it goes through day after tomorrow, a real big push for advising and registration. They've got tables set up in the new Academic Success Center on the Birmingham campus. It's technically on the west campus, but it's right across the street from the east campus. And they'll have people there from 9 in the morning till 7 in the evening at those tables, and they'll have tables for every major possible, not per major, general studies, pre-nursing, health professions, career tech, whatever area you're in, there will be somebody there. I think business has a table. I forgot, left them out before. Business has a table on both campuses, so there will be tables set up. There'll be plexiglass between. Everybody will be masked. You will be masked, and you can get all the advising you need, help with registration, financial aid, whatever you need. There should be somebody there to help. Okay, now Bessemer campus, it'll be in the Ethel Hall Auditorium. That's not the Ethel Hall Nursing Building on the Birmingham East campus. That's the one on the Bessemer campus, and that's sort of on the south end of the campus, the entrance in between the Civic Center and the light at the hospital. The entrance there, that's the easiest entrance, but you can go into the light at the hospital, and then you have to circle the A building, come back to that parking lot that the other entrance enters. So please, the safest thing would be to sign up for virtual advising, get your virtual advising, and then register. Okay, if you find you want to talk with someone, you want to go on campus and do this, then by all means take advantage of the time that's there. There will be people there, and get registered for spring. Okay, now let's get on. We're in example 6. We've already started. What we're showing here is the x minus 2, and you see the x minus 2, you put the 2 outside the box here, not minus 2, 2, always the opposite, and then put the coefficients of your dividend inside the box. This is synthetic division. We put those there, and then we proceeded and found out, sure enough, x minus 2 is a factor of this. So you've shown the first one. Now what that also means is that x equal 2 is a solution for that polynomial. And you could take time and do that and show that's indeed the case. But they also wanted you to show that x plus 3 was also a factor. Well, guess what? If x plus 3 was a factor of this, then x plus 3 will also be a factor of your quotient. Okay, so what we'll do now is put another box here and put the negative 3 here. It's always the opposite of this. Okay, and we'll skip a line, draw a line just like we did before, bring down the 2 just like we did before, and then multiply and add. Negative 3 times 2 is negative 6. 11 minus 6 is 5. Negative 3 times 5 is 15. Is negative 15. 18 minus 15 is 3. Negative 3 times 3 is negative 9. And ding, 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 we have another winner. Okay? The negative 9 plus 9 is 0. That means that was also a factor. So you've now shown first that this was a factor because it had a 0 remainder, and this was a factor because it had a 0 remainder. Now, the next thing it says is find the remaining factors. Well, when you get to a quotient that only has 3 numbers in it, this would be the constants, that would be linear, this would be quadratic. That's exactly what it is. Oh, and by the way, this also means that x equals a negative 3 is also a solution to that. You could plug that in and you would see that is also a solution for that polynomial. Okay, but let's do what they're saying here. Find the remaining factors. Rewrite this as a polynomial. That would be 2x squared plus 5x plus 3. Let's see if we can factor that. If we can't factor, you could use the quadratic formula. But let's see if we can factor. The only possible factorization of 2x squared is 2x times x. Okay, now if you have any questions, pop on in here, folks. Don't be shy, okay? So 2x times x, that's going to give you 2x squared. Now that's not the only factorization. It could be an x times 2x. We'll just have to see. Next, we look at the sign of the last term. That's positive. That means these two signs have to be the same. So we look at the sign of the middle term, that's plus, so this has to be plus, and that has to be plus. Now, the only factorization for 3 would be 1 and 3, or 3 and 1. Okay? Now, just from experience, I know the 3 should go here, and the 1 should go there. Now, how did I know that? Well, because, let's FOIL it and see. 2x times x is 2x squared. 2x times 1 is 2x. 3 times x is 3x. 2x plus 3x is 5x. And then 3 times 1 is 3. So that works. So we found the remaining two factors. There's the first two. The last two are 2x plus 3 and x plus 1. Which also means the last two solutions to this are x-intercepts, or whatever you want to call it, of it. One is going to be x is equal to minus 1. That comes from this one. That's x equal minus 1. And from this one, it would be x equal minus 3/2. If you set that equal to 0, that would be a solution. And then subtract 3 from both sides, divide by 2. Set this equal to 0, subtract 1 from both sides. Now, I'm going to, my internet connection is unstable, as if we did something else that happened this morning. Okay, did I break up some in the middle there? Yeah, sorry about that. Am I clearer now? Okay, good. Okay, that's why I quit teaching when that shows up, and I just talk so you can hear that I'm still there. Okay, I want to point something out to you, okay? And this is jumping ahead. We're going to do it in a couple of sections from now. But I just want to point something out to you, that notice there's a plus, plus, minus, minus, minus. That means there's only one sign change in here. And this is jumping way ahead, so don't get bent out of shape on this or anything. That means we only have one positive real root to this polynomial. And sure enough, there it is. The x equal 2 is your only one. These three are all negative. Okay, we'll get to that later. Here's another thing I want to point out to you. When you did that first division here, dividing by 2, and you wound up with all positives in your quotient, that was another sign to you. That was saying that's the greatest solution you have, root that you have. Okay, Asher, did you need something, or is your microphone just on? Okay, I can't tell. So when you wind up with all positives down here, don't ever look for another positive value greater than, in this case, that 2, because that you've maxed out. Anything greater will give you bigger numbers here. Same thing here. You had all positives here. Your next two solutions were both negative. Okay. Just a couple of other little things we'll get to in 2.5. But this, I think, wraps up. Let me start by, well, let me see. Yeah, let me start by erasing my stuff. Any questions before I erase it? Any questions? Okay. See how they did it. They start by using synthetic division, because this has a coefficient of 1, exponent of 1. So you put not minus 2, but 2. If you're solving this as a 0, you'd say that equals 0. then add 2 to both sides, you get x equal 2. So put the 2 on the outside the house. They do their house different from me. And then put the coefficients here. 2, 7, -4, -27, and -18. And then skip a line, draw a line. They don't say that, I do. Bring down the 2, then you multiply and add. 2 times 2 is 4, 7 and 4 is 11, 2 times 11 is 22, minus 4 plus 22 is 18, 2 times 18 is 36, -27 plus 36 is 9, 2 times 9 is 18, -18 plus 18 is 0. 0 remainder. I like always to block that off. They don't do it, but I do. That lets you know this is the quotient part, this is your remainder. And since the remainder is 0, and your remainder theorem said that f of 2 is equal to 0, that means x equal to, x minus 2 is a factor, and x equal to is a root to that polynomial if you set it equal to 0. Okay, so 2 things that means. Okay, so you've answered the first one, show that it's a factor. Now what we have to do, you don't have to go back to the original polynomial. You can use the polynomials that's left over, your quotient, and then do the same thing with x equal -3. So that's what they're going to do next. So take the result of that division, your quotient, perform synthetic division again using the factor x plus 3. If you set that equal to 0, subtract 3 from both sides, you get x equals -3. That's what you put outside the house. The quotient that you had before, 2, 11, 18, 9, that you write up here, skip a line, draw a line, bring down the 2, and now you do synthetic division again, because this has a coefficient of 1, exponent of 1. -3 times 2 is -6, 11 minus 6 is 5, -3 times 5 is -15, 18 minus 15 is 3, -3 times 3 is -9, 9 minus 9 is 0. Ding, 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 you have another winner. Okay, and I can't find my pen. There it is. I like to separate what we have here is the quotient. Since you only have 3 terms, that means it's a quadratic expression. Quadratics, you don't need to do synthetic anymore. You can factor or use the quadratic formula. So anytime you get down to 3 terms in your quotient, stop there and either factor or use quadratic formula. Okay, and again, because you get a 0 remainder, you know that f of -3 is equal to 0 from the remainder theorem, which means x equal to -3 is a solution to that original function equals 0, and x plus 3 is a factor. So what do we do from here? We try to factor your quotient. Okay, so let's see how they did that. Because the remaining remaining expression is a quadratic expression, try to factor it. And sure enough, they factored the same way we did, 2x plus 3 times x plus 1. And so your complete factorization would be the x minus 2 that we had at the beginning, x plus 3 that we found out here, and then the 2x plus 3 from there, and x plus 1 from there also. That's completely factored polynomial. Now, there will be something else we're going to hit later that will tell you that every polynomial function can be factored into either linear factors like these are, or irreducible quadratic factors. Quadratic factors you cannot factor or use a quadratic formula on. They just will not factor. Okay, that'll be coming later, but we've finished this one. And I believe that's it for 2.3. Any questions on this example or anything in 2.3? Okay, if not, let's just see if that is the last slide. Yes, it is. I'll discard this, and what we're going to do now, I'm going to do a couple things now. First, I'm going to close this out unless there's question about it. Okay, And I'll pick up my screen share with 2.4, but we won't go there yet. And now I've got to adjust everything again. So let me get that readjusted here. Sort of a pain in the neck, or some other body part. Okay, now before we move on to 2.4, let's do the vocabulary in 2.3. If you got your books, open them up and look at them. If you got your ebooks, see if that will work too. I don't know if you can do everything on the same device, but it says 2 forms of the division algorithms are shown below. Identify and label each term or function. Okay, so what I'm going to do for this one, I don't usually do this for vocabulary, but I will. Let's go back here, and now all this stuff, not all of it, part of it is out of order again. I'd already moved the toolbar out of the way, which you can't see, and it wouldn't be in the way for you. And can you see my whiteboard? It says screen sharing has stopped, but it says I'm screen sharing. Can you see the whiteboard? Yay or nay? Can you? Anybody? Can you see the whiteboard? All you see is white. Is that right or not? Okay. I hope that was a yes. Okay, good. Thank you. Here is the first expression of the division algorithm. F of x is equal to d of x times q of x plus r of x. Yeah, this thing is such a pain in the neck. Okay, now it said identify and label each term or function. What is the f of x called? That's the biggie. That's the dividend. The d of x, another d word, that's the divisor. Okay, that's supposed to be an r there. Okay, that's the divisor. This goes into that. This then, of course, is your quotient. That's the answer for a division problem, or at least the first part of the answer. The second part may or may not be a remainder. Okay. Now, the other way to write this is to divide everything, all 3 terms here, by the divisor. So that would be f of x over d of x is equal to, and when you divide this by the divisor goes out, and all you have left is the quotient of x plus, and when you divide the remainder by the divisor, you have r of x over d of x, because you divided all 3 terms by d of x. These names are still good. The dividend is your big one on top. Your divisor is the one on the bottom here or here. Your quotient is your q of x there, and your remainder is r of x there. Now, here's just a couple of things. In order to do either long division or synthetic division, remember the f of x, your dividend, has to be a polynomial of degree greater than or equal to d of x. Has to be. So this is what they call an improper rational expression. The degree of the numerator is greater than or equal to the degree of the denominator. That also means that the remainder has to be degree less than the divisor. So this has to be a proper rational expression. Degree of the remainder has to be less than the degree of the divisor. Okay, so that was vocabulary number 1. Vocabulary number 2 is a fill in the blank. So let's see if we can do this without writing. In that division algorithm, the rational expression r of x over d of x, this one right here that we still have written on the board, okay, I think I just said this, is blank because the degree of r of x is less than the degree of d of x. What would that blank be? I just said it a few minutes ago. Whether you lift your little pinky when you drink your tea or not. That's a dumb hint. Anybody have an idea? That's called a proper rational expression because the degree of the numerator is less than the degree of the denominator. In this same division algorithm, the rational expression f of x over d of x, this one, okay, that rational expression is blank because the degree of f of x is greater than or equal to the degree of d of x. What does that make that expression? You don't lift your pinky. Anybody? That's improper because the degree of the numerator is greater than the degree of the denominator. Because that's true, you can divide, okay? And you'll get an answer, okay? Number 4, a shortcut for long division of polynomials is blank blank, in which the divisor must be of the form x minus k. What is that type of division called? It's a shortcut for long division. We just did it twice in the last example. Anybody? Synthetic division, perfect, okay. Number 5, the blank theorem states that a polynomial f of x has a factor of x minus k if and only if f of k is equal to 0. Anybody? I'll read it again with emphasis added. The blank theorem states that a polynomial f of x has a factor x minus k if and only if f of k is equal to 0. What's that theorem named? Oh, come on. Factor theorem, good one. Okay, number 6. The blank theorem states that if a polynomial f of x is divided by x minus k, then the remainder is r is equal to f of k. What would that theorem be named? Do I need to read it with emphasis? The blank theorem, anybody? The blank theorem states that if a polynomial f of x is divided by x minus k, then the remainder is r is equal to f of k. Remainder theorem, y'all are really quick. Okay, good, thank you. Homework exercises here would include number 7, which you can find at calcchat.com. Number 9 is at calcchat, should be anyway. Any of the odds 11 through 23, they should all be at calcchat. 19 should be at calcview. Any of the odds 25 through 43, they should all be at calcchat. 27 should be at calcview. Any of the odds 45 to 49, they should all be at calcchat. 51 or 53 should both be at calcchat, with 59 being at calcview. Any of the odds 55 to 61 should all be at calcchat. By the way, these are on pages 142 to 144. Okay, the ones I'm calling now are on 143. 55 to 61 should all be at calcchat. Odds 63 to 69 should all be at calcchat. 63 should be at calcview. 71 to 75 should all be at Calc Chat. 77 or 79 should both be at Calc Chat. Then some applied problems, 81 should be at Calc Chat. True false, 83 or 85 should both be at Calc Chat. Think about doing 87, that should be at Calc Chat. And then you can do 89 as an error analysis. I really don't like them as much, but they've made a mistake here. You need to find the mistake. Okay, that's what they're saying. I really don't like those because I hate for them to make mistakes in the book and you think they're right or something. So, but they make a big red X showing what, but you have to figure out what's wrong. Okay, that's 89. It should be at Calc Chat. And finally, 91 should be at Calc Chat. Okay. Oh, 91 or 93. No, okay. 91 should be at Calc Chat, and you can think about doing 93. It should be at Calc Chat as well. Okay, now, the next section we're going to do, 2.4, was not in the course description, okay? But what you're going to run into, you'll need to know some of this. So we're going to do this, but it's mostly going to be a slideshow, okay? I will do a little bit just to give you a clue of what's going on, but we're not going to take as much time as we normally do. Here's another thing. Now, I can't remember if I did this last week or not. Last week turned into a really horrendous week, okay? As some of them haven't been. Okay, did I put your third test out there yet? Has anyone checked? It was a really short test. It used to be Quiz 2, but now says Test 3. Say again? Okay, good. I thought I did, but I just couldn't. It's been, goodness gracious, so many things have been happening. Just for instance, those who were here early, I told you we're having furnace problems here at the house. Upstairs is okay, we're on a heat pump. Downstairs is cold, okay? So that's why I'm upstairs like I normally am. So this has just been a pretty crazy week. The guy's supposed to come by. A guy came by yesterday. He said it's not really repairable or be very expensive to repair. So another guy's coming by to give us a quote on the new furnace, which is always wonderful to know. Okay, so anyway, let's move on to 2.4. Now remember, you're not going to be tested on this, but you will run into this. So that's why I'm covering it. Okay, and here's 2.4. Okay, so the clock starts now on test 3. You have 1 week to do it, but guess what? You have 2 weeks, right? Because next Tuesday is, well, next week is Thanksgiving week, and as far as I know, no students are required to be in class next week. Are you? Is that your understanding? Yay or nay? As far as I know, faculty members have, staff have professional development Monday, Tuesday, and Wednesday, and then Thursday and Friday are holidays. So you have the week off. We don't. We have Monday, Tuesday, and Wednesday to work, but then on Thursday and Friday, everybody's off. So you can still get business taken care of at the school Monday, Tuesday, and Wednesday of next week, but I would not wait till too late on Wednesday, because they start letting people go usually sometime in the afternoon. So you may not find who you're looking for in the afternoon on Wednesday, but Monday and Tuesday school should be open all day long. And you can contact us. We'll be at our computers or whatever, so you can contact us. But anyway, just a word. So you have until the Tuesday after Thanksgiving. Now, you have more time if you need it, but please, we're running out of term. That next week after Thanksgiving, last week we got. So let me go on with the screen sharing here. Let's go to current slide. All right, we're still in Chapter 2, Polynomial and Rational Functions. We're now going to do 2.4, Complex Numbers. Again, it was not in the course description, so I'm just going to do basically a slideshow and fill in a few gaps here and there. Okay. We'll use imaginary unit I to write complex numbers. We'll add, subtract, and multiply complex numbers. Notice I didn't say divide. That's the next objective. Use complex conjugates to write the quotient of two complex numbers in standard. So this is our division then. And we'll find complex solutions for quadratic equations, and that's what you need to know. That's why they have this in here. So let's start with the imaginary unit I. Now I don't have my watch on. It's being recharged right now. So, oh, here's my telephone. It's right here. Let me keep up with time here. We have about 15 minutes. Okay, you have learned that some quadratic equations have no real solutions. For instance, can you find a number that when you square it, oh, here's Terrell. He must have had to get out and come back in. So hopefully he's back now. Okay. I think we've lost some other people too, perhaps, because I don't think the numbers are as high as they were. Okay. Terrell, I'm guessing your microphone's on. Or it's Ashford 1. I don't know. Somebody has a microphone on. Okay. Can you come up with a number that when you can square it and add 1 to it, you get 0? No, not in the real number systems, because any number you square in the real number system is going to be positive. Any number except 1, 0. If you square 0, you get 0. Well, if you add 1 even to 0 or to any positive number, you can't get 0, okay? There's no real solution because there's no real number x that can be squared to produce a negative 1. Okay, and that's what you would have. If you subtracted 1 from both sides, you'd have x squared equal minus 1, and you know there's no real number that'll do that. To overcome that deficiency, mathematicians created an expanded system of numbers using what they call the imaginary unit I, which is defined to be exactly what we're missing here. Square root of I, the square root of negative 1 is I. There is no real number that could be, but there's this imaginary unit I. So another way of looking at that is that if you square this, you get I squared. Square this, you get a negative 1. That would solve that equation. The solution would be plus or minus I. Okay? So, why this won't advance, I don't know. Okay. By adding real numbers to real multiples of that imaginary unit, you set up a whole new set of a number system. And this is called the complex number system. Okay? Now, each complex number can be written in standard form of A plus BI. A is a real number, B is a real number, I is that imaginary unit called the square root of negative 1. Okay? Now when your B is 0, the complex numbers is a real number, strictly a whole real number. If the A was 0, then this is what they call a pure imaginary number. There's no real part to it. It's all imaginary. Okay? So every number we've ever used in your life is a complex number. It's just that most of those have had B is equal to 0 here. Okay? We've been in the real number system our whole lives here. Okay? Now, here's a for instance. The standard form for the complex number minus 5 plus the square root of negative 9. Now we look at that and say, there's no number that's the square root of negative 9. There's no real number. But you see, what you can do is factor this negative 9 into a negative 1 times a 9. Well, the square root of negative 1 is I. Square root of 9 is 3, so this would be negative 5, and they always like to write the B in front. That would be 3i. So there's the complex number that corresponds to that expression. Okay? Now, what you can do with this, minus 5 plus the Square root of negative 9 would be minus 5 plus, now I don't know why, okay, they're just showing the same thing I said earlier. To me this is an awkward way to do it, but it's perfectly right. That's the square root of 3 squared, that's your 9 part, times negative 1, that's the negative part, okay? And then split that into two pieces, negative 5 plus the square root of 3 squared, which is 3, times the square root of negative 1, which they left it there, I don't know why. And then that's negative 5 plus 3 times I. The square root of negative 1 is I. Okay, they went to gory detail there, but that's correct. Okay, that's the complex number that represents, that's the standard form for the complex number that would be this entity here. Okay, so here's a definition of a complex number, a lot of blah 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 here. A and B, remember, are both real numbers. That means no imaginary part to them. The number A plus BI then would be the real part plus a real number times the complex entity. That's called the complex number. So if you think back, let's just have a pause here. Think back, the very first number set that you ever used was your counting numbers. You just counted 1, 2, 3, 4, 5, 6. They were called the natural numbers or the counting numbers. And then at some point you added 0 to those counting numbers. 0, 1, 2, 3, 4, 5. That was the set they called the whole number system. Okay? You included 0 with it. And then you included the negative of those. Of all those counting numbers, do the negative, that was a set of integers. Okay? Then at some point you ran into the ratio of any two integers, as long as that bottom one is not 0, because you can never divide by 0, that gave you what they call the rational number system. Ratio of any two integers as long as the denominator is not 0. And then, because you ran into problems that you couldn't, and by the way, the rational numbers were a ratio of two integers, or another way of looking at it, if you wrote it in decimal form, it either was a terminating decimal or a decimal that repeated some unit forever and ever and ever. Those were rational numbers. But we ran into numbers that never repeat a unit forever and ever and ever. Those were called irrational numbers. The square root of 2, the square root of 3, the square root of 5, the square root of 6, the square root of 7, cube root of 2, cube root of 3, cube root of 4, lots and lots of irrational numbers, including things like pi, e, and those kind of numbers. Those are irrational numbers. And then when you combine the rational numbers with the irrational numbers, that gave you what they called the real number system. So now we're expanding the real number system, or expanding, adding to that to make the complex number system, which have these imaginary units in them. Okay, so all real numbers are complex numbers, but not all complex numbers are real. It is said to be written in standard form when you write real plus real imaginary. Okay, that's what it is. The real number A is called the real part, and the real number B is called the imaginary part. Now, frankly, I call BI the imaginary part. They call just the B the imaginary part. So if you get me saying something that's not quite together with the book, that's why. Because why not include the I in there? Because that makes it imaginary. Okay? So when B is equal to 0, this number, A plus BI, is real number. All real numbers are complex numbers. But when B is not equal to 0, the number A plus BI is called an imaginary number. Now, frankly, I want to call that a complex number. It is complex for sure, but so are real numbers. So that's why they call that an imaginary number. If a number in the form just BI, where A is equal to 0 and B is not equal to 0, is called a pure imaginary number. There's no real part to it. There's a real factor, but not a real term. Okay, that's called a pure imaginary number. Okay, so that's the nomenclature. So the set of real numbers is a subset of complex numbers, because all real numbers are complex numbers, but not all complex numbers are real numbers, because you have the imaginary numbers down here which have an b not equal to 0. Up here the real numbers, the b is equal to 0, here the b is not. This is true because every real number a can be written as a complex number a plus bi, where b is equal to 0. Okay, that is, every real number a you can write, yeah, what I just said, a plus 0i. Who would want to write that? I don't know, but you could. Okay, perfectly legal in most states. Okay, now what do we mean to say that two complex numbers are equal to each other? So two complex numbers, a plus bi and c plus di, written in standard form, are equal to each other, a plus bi equals c plus di, if and only if a is equal to c, the real parts are equal, and b is equal to d, the imaginary coefficients are equal. That's the only way. 2 plus 3i is not the same as 3 plus 2i. They have to be, a and b have to be identically the same. B and d must be identically the same. Now, b could be 2/3 and d could be 6/9. Well, those are the same values, okay? So they don't have to look the same, but they have to have the same value. Okay? Now, and we're going through this really quickly. I'm not stopping and doing any examples that we're missing. But let's move on to, in fact, we haven't done any yet, operations with complex numbers. Well, first operation you ever learned was adding. After you did counting, you did adding. Okay? To add or subtract two complex numbers, you add or subtract the real parts and the imaginary parts separately. Okay? Just like you do with like terms. A complex number is a binomial. Two terms. One real term, one imaginary term. Okay? Think of it that way, and you just add like terms. So addition and subtraction of complex numbers for two complex numbers, a plus bi, c plus di, written in standard form, which they are. The sum and the difference are like this. The sum is a plus c plus b plus d times I. You add the real parts, that gives you a real number. You add the imaginary parts, that gives you an imaginary number. That's it. The difference, do the same thing you do with any signed number. A plus bi minus c plus di would be a minus c plus b minus d times I. That's a real part. That's an imaginary part. You just do it. Now, if these numbers c and d had signs that were not positive, then you change signs and add. Just like you, oh, here's d. He must have gotten bumped out or had to leave, but he's been here before. Let me make sure I've got him marked. Yes, I do. Make sure he's here. Okay. Now, any questions on adding or subtracting? Oh, here's Terrell had to come back in. Okay. Glad you made it back. Okay. Any questions on adding and subtracting signed numbers? It's just like terms. Add or subtract the real parts, add or subtract the imaginary parts. Okay. Now, let me see if I can get it to advance. There we go. Now, the additive identity in the complex number system is the same as it is in the real number system. It's 0. Now, if you say, but wait a minute, 0 is just a real number. It's not. Yes, it is imaginary. It's 0 plus 0i. Okay? You just put a 0 for both the a and the b. Now, furthermore, the additive inverse. This is additive identity. The additive inverse of a complex number is just the opposite of that number. This is a plus bi. That would be the opposite, meaning the negative of that, which would be negative a minus bi. Why is that the additive inverse? Because if you add this number, a plus bi, to this number, minus A minus BI, you get A minus A is 0 plus B minus B is 0I, which is just the number 0. And that's what an additive inverse is. It's anything that adds to another number to make it 0. The additive inverse of 7 halves would be minus 7 halves, because you add them together, you get 0. Same thing here. Both the real and imaginary parts must add to be 0. Any questions so far? So let's do this quickly. I don't do anything very quickly. How's our time? Oh man, we don't have any time, do we? Okay, so sorry, I had hoped to finish this time. We will start next time with example 1. Okay, and we're going to go through these very, very quickly, because you're not really responsible for this, but you need to know the subtle things and not too subtle things about it. And somehow I've lost my pencil. I had a pencil here and it has flown the coop. I don't know where it could have gone. Ah, here it went, behind my computer. Okay, so we'll start with example 1 next time. There's really no homework exercises you have to do here, because you're not responsible for this. However, any of those that you want to do, you certainly can. That would be 7 or 9. They're both at Calc Chat, and that's really all we did. No, actually, you could do 11 through 21, and they're all at Calc Chat. 11's at Calc View. Again, you don't have to do this, but you could. And adding and subtracting, we've talked about it, but haven't done it. So hang off doing that, and you can do that next time, or you cannot do it at all. That's up to you. Any questions? Okay, so we will meet on Thursday, the 1 week before Thanksgiving. Please be here. We're going to finish 2.4, knock on wood, and we're going to get into 2.5, which I think is the most important section in this whole chapter. It ties everything we've done in the first 4 sections together in 2.5. It's a long section. We need to get it done, so we'll be ready to finish it up the week after Thanksgiving. Any questions? All right. If not, I'm going to stop sharing. I'm sick and tired of sharing here. Any questions before I end the meeting for everybody?
When is the second test due?
Technically a week from today, 2 weeks from today, because next week is Thanksgiving. But oh wait, second test, the big one. Get it to me as soon as you can. It's already technically past its due date, but I give you as long as you need to do it. Just get it to me. I'd like to have had it before I gave out the 3rd test, so try to get to it as soon as possible so you can get working on the 3rd test. Okay? It's out there somewhere, they told me. I meant to put it out there, but I couldn't remember if I had, because last week is week 13. Yeah, it's there. Did I also put it under Blackboard messages? I usually do, but I don't remember if I did or not. Anyone check it? Okay. The 3rd test is both at week 13 under it'll say test 3, I think, and then it may also be at the Blackboard messages. Just check those and see if you can see test 3 there too. I can't remember if I put it both places. I usually do, but I know it's at week 13, test 3. Okay? That's under Blackboard. Any other questions? Okay. I need to go on and end the meeting. I've got another class coming up at 10 o'clock. So, any questions? All right. Take care, folks. We'll see you all and more, hopefully, on Thursday. Okay? Take care. Bye-bye.